Bismillahirrahmanirrahim. So we are going to just go over the two articles that we have been assigned. So here's the question. There was actually a court case. This was this lead additives industry. What they do is they add this solution into the petrol, which makes it high octane, gives it more power, but it also has lead. So there are 4 producer firms. 2 are big with excess capacity, 2 are relatively small, 18% and 12% market shares. There are about 10 large buyers which have 60% market share, and there are a total of 150 buyers. So this is the market structure of the industry. 4 sellers, 150 buyers, but 10 large ones. Now there are certain practices in the industry, and there is a case that these firms should be prevented from these practices. So there are these 3 practices: that all the firms announce their prices in advance for the month, and near the end of the month, some 3 to 8 days before, they must, if they are planning to change, then they must announce that we are planning to change prices for the next month. So this is one of the microstructures in this industry. And then the contracts they sign, they have most favored nation clauses, which means that if you sell to somebody, especially the large buyers, you guarantee that you are getting the smallest possible price that I will get. So I will not give a lower price to anybody else. So there are no special discounts for anyone. And finally, the price that they are offered is the delivered price, which means that there can be no negotiation about the price which is hidden in the transport cost. So the full price, the exact price, the correct price is known to everybody. So this is an important thing, because if the delivered price was not there, then if this was the price at the point of sale, then they could the delivered price could be different, and then they could do some sort of price discounting on the delivery costs, for example. So now the question that was in court was that, does this make any difference? Are these prices going to be, then suppose we drop all these 3 practices and say, no, you don't have to announce prices, you don't have to give notice, and you should not put in most favored nation clause. Everybody can negotiate their own price. Will that help or will that hurt? So according to the some economists, there were economists on both sides. According to some economists, this doesn't matter. Basically, you have an industry structure which is 4 industries, and so this is an oligopolistic situation, and these practices are not relevant. Whatever the industry structure is, that will determine what the prices come out. So whether the industries announce prices or they don't, this should not make any difference. Similarly, all of these contracts, they should not have any effect. So the Federal Trade Commission says, no, these practices matter. If we did not have these practices, the customers would have lower prices, and the four firms who are sellers, they will have smaller profits. These rules allow the firms to take advantage of the consumers. So the question is, how can we find out? So economic theory offers us no guidance about this, because we can calculate the supply and the demand and we can come up with it. But of course, as we have discussed in the last semester, supply and model doesn't work here. So this is a mistake to think. Why it doesn't work? Because supply and demand is a perfectly competitive model. All of the firms should be price takers. So the issue of whether they post prices or not is irrelevant. There is an equilibrium price and everybody is forced to use only one price. And if there is any deviation from the price, then either no one will buy or everyone will buy. That's full information, zero transaction cost assumption. So that theory simply doesn't work. When you go out of the competitive supply and demand, then economists don't really have any theory. You have oligopoly theory, but then you have Bertrand competition, and we have Cournot-Nash equilibrium, and leader-follower, and Stackelberg, and so you don't know. You can derive many different kinds of solutions, and you don't know what is going to happen. Economists don't have any clue. So the question is, so basically, and if you were presenting this, you could, to an economics class, then you could ask, okay, what do you think? Do you think it makes a difference? Which party is right? There were economists on both sides of this. So the normal economics class wouldn't have an intuition. Since you guys have already seen this article, so you know the answer, but otherwise it's not obvious from just thinking about it whether it would make a difference or not. You can make arguments on any side that, when you post prices, this creates increased information. If you allow negotiations, then it might be worse for the consumers because they will be able to get advantage of. So, it's not at all obvious from thinking what the result should be, that whether posting prices will help the consumers or whether it will hurt. And it seems like it should help, because if everybody posts prices, then you can't negotiate, and everybody knows, so everybody can compete. So you have closer to full information situation. So anyway, the way to find out is to run an experiment. So here was the experiment that was run. The experiment was done by trying to simulate the situation. That is, they looked at the four firms and they looked at their capacities and the supplies, and they looked at the demands, and they tried to create an experiment which was matched to the actual conditions of the market. So here's the supply curve and the demand curve. The equilibrium is at the crossing at 0.54. There is substantial excess capacity at this price. What does this mean? I would like you to learn to read articles and understand them instead of cut and paste them. So this is one of the sentences from the article, so I want to just know what this sentence means. Yes. Nobody knows the answer.
जिन फर्म्स का एक्सेस शेयर है वो मतलब इस प्राइस पे जो है एक्सेस कैपेसिटी
कुछ फर्म्स लार्ज थी कुछ स्मॉल थी जो लार्ज फर्म्स थी वो ज़्यादा शेयर को वो कर रही थी और जो स्मॉल थी वो कम कर रही थी.
But the sentence says there is equilibrium occurs at 0.54. There is substantial excess capacity at this price. So, what does 0.54? What is 0.54? Is there a place in the graph where this occurs? And is this, do we have to use this graph to say that there is excess capacity, or is this some general principle that there is always excess capacity? This graph shows us that there is excess capacity. So what is it in this graph from which we learn that there is excess capacity? What does excess capacity mean? Can you identify where there is equilibrium on this graph? Yes, what's the equilibrium? क्या हुआ? 0.54. Yes, on the graph, how is it marked? There is a dashed line at the 1.54. This is the point at which there is the intersection of the supply curve and the demand curve. So now what is the amount that is being offered at this price? Yani if the price is 0.54, how much supply will be available at this price? Yeah? क्या? Yes, the demand curve is at the axis at 20, and then the next marker is 25, and the next was 30, and the next one is 35. So how much excess capacity, what is the supply that is available at 0.54? Yeah, it's little bit between 20 and 25. And what is the demand at this price? It's not 20, it's less than that. It's between 15 and 20. It's about 18 units, I think. So, what does excess capacity mean?
Supply is more than...
Yeah, the supply is at 22 and the demand is only 18, so there is excess capacity. And what does it mean? It means that, in terms of that, there should be competition. Yani, because there is excess capacity, people want to sell. So the design is favorable to achievement of competitive equilibrium. Because we have seen that if people raise prices above this, they try to raise prices, then since only 18 units or less can be sold at higher prices, so there will be people who have available at least 4 units that they want to sell at even a lower price. So the structure is such that the competition forces are strong. It's not going to be easy to keep the prices above competitive equilibrium, because there's so much profit available to firms. And if they start selling all these things, then the prices will go down. But the standard supply and demand forces are strong here. Now, for each of the units, they have labeled the firm, so you can deduce from the graph. If you want to run this experiment on your own, you can calculate exactly what the cost structure of each firm is. The number of sellers has been fixed at 4. There is no plant expansion, so supply curve will remain fixed. There is no entry and there is no exit. These were assumptions that, you see, they were going to take this result and use this to testify in court. So they need to be able to defend the assumptions as realistic. So they do argue that because of the changing laws, the industry is not expected to expand. It's expected to contract, because the lead additives, they were trying to phase them out because they have harmful environmental effects. So entry is not expected because new firms cannot come in and make profit, and the firms are not going to try to expand plants. So they can say that we can take this supply and demand as fixed and given over the period. So all of these things. All right. So there are they run the experiment with under 4 conditions. The first condition is that N. There are three codes for it: N, A, and L. So N is that no one makes any advance price announcement, and the second is that all sellers make the price announcement. There are 4 of them. And the third condition is only the large sellers announce the prices. The second condition is that all the buyers and the sellers can see all the prices, or only the buyers can see the announcements. So these are conditions A and B. The third condition is whether or not most favored nation clause is in effect. Yes or no. And the fourth condition is that prior notification is required for price increase, yes or no. The delivered prices are automatic in this experiment because you are selling directly to the buyer, so there's no. So the real competition, what the court case is about, is the comparison between N-NN and LAYY. N-NN is the case where no one makes advance price announcements. Dash means that since there are no announcements, whether the condition 2 doesn't apply, whether all buyers see or whether the only sellers see, it makes no difference because there is nothing to see. There are no announcements of price. You directly call up the buyers, call the sellers, and vice versa, and they negotiate over price, and nobody finds out what the prices are. They are not posted, not announced. So N dash and NN, there is no most favored nation and there is no prior notification. So this is the case with the FTC, the Federal Trade Commission is arguing that should be present. And the current situation is LAYY, that the large sellers announce their prices, the small sellers don't have to. A means that all buyers and all sellers see all the prices. That's what happens. That's what's happening in the industry. And Y is yes, most favored nation, and yes, prior notification of price increases. So these are the two cases that we want to compare, and what the FTC is arguing is that LAYY would have higher prices, and the industry is arguing that no, this makes no difference. N-NN and LAYY should have the same price structure, because same prices, because the industry structure is the same. There are four big, and there are four sellers and 150 buyers, and whatever that structure is, that is what determines the price. And these conditions don't have anything to do with the prices. So these are the two parties, and on theoretical grounds you cannot come to any conclusion as to what will happen. And when you go to the real world, again you cannot easily come to any conclusion, because, well, the industry is running some way, and now you can't really run an experiment on the industry to say, okay, you do this and you do that, because it's the real world. So in an experiment we can simulate this. We can just set up 4 people who will be sellers and 10 people who will be buyers, and then we can say that, all right, we will run one experiment under one set of rules and the other experiment under the other set of rules, and then we will see what kind of prices emerge. We will ask the buyers. So you are familiar with this setup. Otherwise, if you are trying to give a lecture on this to unfamiliar students, then you might want to run a small experiment so that they understand what you're talking about. Otherwise, economists don't know anything about experimentation. So if you say, okay, let's run an experiment, they won't understand what you mean. So see, this is the major contribution of science. Before Ibn al-Haytham, there were 2 theories about how we see. It was clear that light plays a role, because if there is no light, then we cannot see in the dark. So now the only issue was, there was one theory that light comes out of our eyes and hits the object, and that allows us to see. And the other theory was that the light comes out of the object and hits the eye, and that allows us to see. And so, based on axiomatic methods, there were hundreds of books written on one theory supporting the one theory and supporting the other theory. And there was no way to decide, because when you study some things axiomatically, theoretically, then you can make anything sound plausible. But so Ibn al-Haytham was the first to say that, okay, when people look at the sun, their eyes gets burned. And if we are looking at something near and then we suddenly look at the stars, we can see it immediately. And that means that if the light takes some time to travel, then it wouldn't happen. That it would take a little while for the ray from our eye to reach the stars. So it would take a while for the star to appear. So basically, he looked at empirical evidence, and this is the origin of the scientific method. Ibn al-Haytham was the first one to introduce. So here again, the economists are using the pre-scientific method, where you set up your axioms and you make arguments using formulas and theories. You never go to the real world to see whether it happens or not. So this experimentation is exactly the application of the scientific method to the economic theory. So now these are the 11 experiments that were run. In the first experiment, in all periods, they did N-N And in the second period, again it was the same thing in experiments 1 to 20. So they just did n dash and n there. In the third period, in the third experiment, for period 1 to 11 they had n dash and n, then 12 to 15 they switched to LAYY, which is the other extreme, and then they went back to n dash and n period 16 17. And then in the fourth experiment, the first 4 periods were run on n dash and n, then 5 to 15 were run on LAYY, and then the last few periods were again on n dash and n. Now, in the fifth experiment, they did ABYN as in the periods 1 to 10. What is ABYN? ABYN is, A means all people publish prices, that is, they announce prices. So this is all means that both the large sellers and the small sellers, so there are 4 of them. And the condition B means that only the buyers see the prices, the sellers don't. Now, what effect would this have? Yani, I would like you to understand so if we choose A or B, what do you think, which way should it go? What difference would it make if we let the sellers see the prices or if we don't let them? Which one would be more favorable for the customers?
Sellers see the prices of other sellers.
Sellers see, तो फिर उससे क्या फायदा होगा? What will?
Price war होगी कि वो less वो sale करने की.
So if the sellers can see, then there will be more competition, he says. What about, is there another opinion about this? क्या हुआ? हाँ, collusion भी हो सकती है. Allowing them to see could also cause them to collude more easily with each other. Whereas if they don't see the prices, collusion is more difficult. So this is the thing, that if you just argue on theory, you cannot come to any conclusion. So you have to go to the experiment to see what really happens, then you can make the argument. Alright, experiment 6, 1 to 11 is n dash and n, and 12 to 18 is LAYY. 7, they did the reverse. 1 to 19 was run in LAYY, and the last 5 periods were n dash and n. And so on. Let's have a look at the, I was going to, I didn't get the time to. I think it's the Grether part paper. Yes. So we can look at this. Where's the graph? This is explaining the mechanics. Now you see, this is not stuff that you need to present. Alright, now I would like to just Okay, what they do is they look at these models and they calculate the competitive equilibrium and the Bertrand competition model and the Cournot-Nash model, and the price leadership model, which is the Stackelberg. You can calculate all of these. They use something, they use some mathematical treatment, but it's not necessary. You can calculate this directly by using the theory that you already know. So, and then there is the global joint maximum, which is if all of the sellers join together and form a monopoly and they maximize profits. So basically they are right, so these are the ways that the 11 experiments were conducted and the results. Okay, so the first two experiments were just n dash and n, and the dashed line is the competitive equilibrium. So what do we learn from the first and the second experiment? This is what reading the paper means, that one is to just report, okay, this is what happened. And this is what not reading a paper, running experiment means, that okay, this is what happened. In the first experiment the price was 93, in the second one it was 90, in the third one it was 90, and in the fourth one it was 75. But this does not reflect any understanding. So what do we learn from this experiment? When you run your experiment, learning should occur. So when you present the paper, then you have to explain what, not just describe what the paper says, but explain what the paper says. So here, what do we learn from this first two experiments?
They are charging above equilibrium price.
Yes. In neither case do we have convergence to equilibrium. That's one of the things that we learned. And the other thing that seems to come out of these first two experiments is that there is some downward pressure on the prices. There is some move towards equilibrium, but it's not strong enough to drive. So basically it's not very surprising, because basically we have two large sellers. So with two large sellers you can't expect to get competitive equilibrium, although in oral double action one often gets, even with such a small pool of sellers, you do get competitive equilibrium. So if we were to actually investigate, we could ask what would happen if you run this same experiment with oral double auction instead of... So actually in 1 and 2 it is sort of like oral double auction, in the sense that no one is announcing prices. People are telephoning each other to get the price. So I don't actually remember exactly how this is done, Yani. Can buyers and sellers both telephone each other, or is it that the sellers only can telephone the buyers? Just the buyers call the sellers and ask. I don't remember how this is run, but anyway, so this is without posted prices. Now 3 and 4, we have in the first few periods you have n dash and n, and you have more or less the same results. It's like convergence to equilibrium, but remaining somewhat above equilibrium level. But then you switch to LAYY. Large sellers announce prices. All changes must be A means that everybody can see all the prices, and you have most favored nation clause, and you have necessary to announce changes. So you see an immediate effect in the experiment. The prices jump up by quite a lot, not a small amount. And then in the last two periods, you switch back to N-N and the prices drop. So what do we learn from this? Yes, it seems clear that the practices matter. So now you see the opposing party said, well, these are artificial experiments, few people playing in labs. How do we know whether this would really happen? So they answer this Grethren plot that, okay, maybe this experiment doesn't apply, they say, quite to the real world. But now you see, you have a theory, this theory fails to work in this experiment. So it's not that this theory is universally valid. But now if you are saying that my theory works in the real world, then the burden of proof is on you to explain, to show that your theory works. Your theory is not a universal truth which always works regardless of. So basically that's what they argue. They don't say that our experiment captures reality. What they say is that the theory that the practices don't matter doesn't work in this experiment. So now if you say that this works in the real world, then now you prove it, because we have shown that it doesn't in our experiment. You run some other experiment which shows, or find some other way of arguing that your theory will work. Now in the fourth experiment, it's quite similar. AAYY is like LAYY. The A means that all sellers announce prices, post prices. So this seems to this seems to basically jack up the prices quite a bit. It's not clear whether the prices are as high as in the LAYY condition, but in principle LAYY and AAYY should not be much different, because the small sellers are announcing prices in AAYY, but they are not in the first one. If we think that LAYY is higher, which it seems to be slightly, that could be interpreted by saying that, you see, when the two large sellers announce the prices, that makes it easier for everybody to collude, whereas if everybody announces prices, then at least for the initial announcement, which is independent, collusions is more difficult. Now the last one in experiment 4, that is interesting. We have A, B and N, which means that all sellers announce prices, only buyers get to see the price, and there are no most favored nations, and there is no announcement required for the next period. So this again the last two, just preventing the announcement and preventing the necessity change, and the sellers don't find out about each other's price. This seems to be enough to generate a lot of competitive pressure. So you can't have the same high prices that you did in the previous period. So now we are learning about the effects of these prices, in the effects of these rules and how they operate. In experiment 5 we have ABYN and AAYN. So here all sellers announce prices. These two are not much different, and either A or B, which means that either everybody sees the prices or only the buyer sees the prices. Yes in the third category means that most favored notion is in effect, but no means that. In the fourth category means that you don't have to announce changes. So now we have almost complete convergence to equilibrium. This is a bit surprising because you didn't get convergence to competitive equilibrium in N dash and N. So here it seems that if you are not committed to in advance, and you can see that basically this kind of structure promotes competition, in the sense that you can see, exactly as one of the students said, you can see the other prices, then you can compete with the other seller by lowering your price instead of colluding. So the crucial, what was the difference here? Why would, we are seeing in one place where announcing prices leads to collusion, and here announcing prices leads to breakdown of collusion. So what is the difference? See, this is the kind of thing that you need to learn from experiments. Why does the same structure, announcing prices, lead to competition in this experiment 5 and leads to collusion in experiment 3 and 4? You have to look at what else is different. हाँ. इसमें ये है कि there is some memory in all of these experiments. Yani people start from the previous period and then they make changes on it. For some reason in the experiment 6, when the conditions changed, the sellers did not stuck to the past, and they did not take advantage of the change. But to come back to the original question, see, how does the cartel break down as per economic theory? They all agree to a price, and then what happens? Yeah. So now, when will the betrayal be possible? In which of these? In 5 or in...
5.
Why will it be possible in 5 but not in 4?
5 में सर वो below equilibrium चलेगी ना.
That's just a random fluctuation. That's not relevant. Experimentation में इस किस्म के होते रहते हैं. बहुत ही मामूली सा फर्क. Why is betrayal possible? Huh?
No one has to.
Exactly. Exactly. It is the N versus the Y. See, if you don't have to announce price changes, if you announce price changes, then as soon you make an agreement, and if somebody betrays, then he has to announce that I am going to betray, and then everybody can follow. So basically, this is the key, that in the cartel breakdown, it is to the benefit of everyone to keep the agreement jointly. And if you betray, then other people can also punish you in various ways by colluding against you. So it's important to be able to betray secretly. If you can betray secretly, that's why secret price discounts versus open price, this is very important in collusion. So what the experiment shows, that if you allow the people to make secret price discounts, that drives you towards competitiveness. Whereas if you force everybody to show their prices, that creates collusion. So that's the difference between the experiment 3, where LAYY prices go high, and in even experiment 4, with AAYY the prices are high, but with A, B and N the prices go down, because now people cannot monitor what is happening. You see, A, B and N is important because the sellers announce prices, but they can't see each other's prices. So if somebody betrays, you can't tell. You don't have to announce any price change. So now cartel agreement is very difficult to monitor and ensure. So basically, actually, explicit collusion was banned in all of these games. But so what we are looking for is implicit collusion, that people are working with each other without actually talking about it. So in situations where you have to announce price increases, then it's easier to collude. And if you don't have to announce them, it's difficult to collude. So that's the result that we are seeing here.
In experiment 6, LAYY is suitable for collusion.
Yes, it is true. Here in experiment 6 is an anomaly. It should have jumped up the price, but it didn't. And this is sometimes happens that when the subjects are playing in a certain way, then they just keep playing in that same way without realizing that the new situation allows for some new strategy. Like we ran an experiment here where we changed the rules and it allowed the students to make a lot of profit, but they did not take advantage of this because they did not see the opportunity until I pointed it out. So in experiment 7 you have LAYY, you have high prices stabilized, but as soon as you switch to ABNN, where people cannot see what is happening, the all buyers announce prices, but they don't find out what the other seller's price is, and they don't announce changes. So now they can betray the agreement. So it's now very hard for sellers to monitor. The previous level, the high level, was good for all of them. It was making them profits. It was bad for the sellers. But now when you can't see what the other guy is doing, then you can make profits by lowering the price, and everyone does so, and they can't find out what the other guy is doing. So now you have lower prices in the ABNN. In experiment 8 they start out with ABNN. So you see, the reversal is also important because because the sequencing matters usually. So in experiment 8, ABNN basically drives the prices towards competitive equilibrium, but now when you switch to LAYY, it jumps up, but it starts at a low level. If you look at experiment 7, it doesn't start at a low level because from the beginning they start quite high. But here the condition in the past, the prices have been low, makes the initial point low, but now it starts rising. And when you switch to LANY, which means that you drop the most favored nation clause, that doesn't seem to have any effect. It keeps rising. So the most favored nation clause does not matter so much. It's the last one, the announcing of prices, that makes easy to collude. That's the most important thing. So in experiment 9 and 10, N-NN is driving the prices low, but doesn't converge to equilibrium, unlike the case of experiment 5 and 6, which is a bit anomalous that you get convergence. But in 9 you get same as previous experiments, the prices are gradually converging towards competition, but not there. And then when you switch to LAYY, then suddenly they jump. And in the last few periods, if then we are AAY, then it doesn't jump down. Now notice the difference between this experiment and the previous one. We have AAYN. So here, all the sellers see all the prices. So it is possible to see, you have now a history where you have maintained prices at a high level, and so even when you switch the last condition, that you don't have to announce price changes, you can maintain that level because you can see what the other guy is doing. So on the basis of this, if we go back to experiment 7 and we say, okay, instead of ABNN, we will do AANN, all the sellers get to see, then we could conjecture that you wouldn't get that jump down because the sellers are practiced in maintaining a constant price at about 80, and as long as they can see that everybody is playing by the same rules, they will be able to continue to maintain this. But when in ABNN they can't see what the other guy is doing, so now it's possible for you to cheat on this agreement because nobody else will find out. So that's what happened. So we can conjecture or hypothesize, and this is what you have learned, that in your research proposal you have to have a hypothesis. This is ridiculous. It's not hypothesis. Hypothesis is an idea about how the world works, and this is a hypothesis, that Now we have some understanding of how this experiment works, and so on the basis of this understanding we think that if I ran experiment 7 again but changed ABNN to AANN, then my expectation is that the prices would not jump down like they did in this one, because having practice with having maintained an agreement, they would be able to continue to maintain this agreement. That's what experiment 9 seems to suggest. Otherwise, we have other examples where switching from the Y to N caused a big decline in the prices. So in experiment 10, we start out with all sellers see all prices, all sellers announce prices, and everybody sees all the prices, and there is the most favored nation clause, but there is no pre-announcement. So in this we have something strange, that you have a convergence to competitive equilibrium, then you have a jump up. So it seems that all the sellers, they were competing for a while until period 5, and then they realized that we're not making much profits here, so they raised the prices, and so there are many different models that can be used to explain these results. But one thing that is important to understand is that what the economist will do here is to try to construct a model in which the equilibrium behavior looks something like this. But this is not the right way to try to understand. What we should do is that go to the people who were participating in experiment 10 and we say that, okay, what was it that prices were going down until period 5? What happened in period 6? Why did you decide to raise the prices? So, if we can find out the answer to this question, then we will know what is happening. So we have to learn how people behave, and people do not behave according to the theoretical models. So this is something which even behavioral economists don't understand for the most part. So they are always trying to make models of behavior. They are not asking people, and they are not trying to find out, because they have in their mind that the people are always optimizing. So they already know how people behave. The only question is to find out which function they are maximizing. So now the AAYN sets you up at a equilibrium, a certain type of customary behavior, and now when you switch to LAYY, people more or less maintain that behavior. And then in the last condition where you have LANN, what's happening is that the large sellers are posting prices. Everybody finds out all the prices, but there is no most favored nation clause, and there is no announcement. So now this seems to cause a decline in prices. Experiment 11, you have LAYY followed by LANN. This time there is no decline. This is exactly the same situation. Basically, people follow through doing whatever they were doing in the first period, and they continue. Alright, so that's basically the results. So let's look at the conclusion. Average price under treatment is higher than LAYY is higher than under the treatment N-NN. So that's obvious from the graph. We don't need to do any t-tests or anything. And basically that's the thing, that the data itself gives you the information. You don't need to run regressions or anything. So, continuing, there is a little difference between AAYI and LAYY. What does that mean? Well, A is all sellers announce and L is only the large sellers announce. So this doesn't make any difference whether the small sellers announce their prices or whether they don't. This doesn't seem to make much difference. That's not a big deal. ABNN is also similar to N-NN. Means that all sellers announce prices, but only the buyers find out, and there is no pre-commitment. And we saw that this was also true, that since when they cannot see each other's prices, then they can betray agreement. It's hard to collude. So basically, now the LAYY treatment itself doesn't generate a stable high price. In different experiments, the same condition, some groups charge a much higher price, some had a lower price. So basically what's going on, you see, at one level we have the description. This is what happened. At the real thing is to understand that description. Why did that happen? So the dynamics of this is that what we can understand is that what is going on which drives this is tacit collusion. That is, without actually being able to communicate, people are trying to collude. So in the conditions in which collusion is easy, they seem to achieve it. Now the collusion occurs that, okay, let's all agree to maintain a certain price level. So since people are randomly trying different prices, whenever they reach an agreement, they say, okay, let's maintain price at that level, but that level itself can be quite variable. So LAY doesn't lead to a specific fixed price because there is tacit collusion, there is not explicit conclusion. If people are allowed to talk, then they will say, let's all keep the same price and let's all keep it at a high level. But since they are not allowed to talk, then this emerges. So the conclusion is that the practices together operate to decrease price competition beyond that which could be attributed to structure alone. The second conclusion is that N-NN doesn't lead to competitive equilibrium. And so basically we saw that in most cases N-NN was maintaining prices comfortably above the competitive level. However, conclusion 3 is that N-NN comes closer to competitive equilibrium than any other model. And so it comes close to competitive equilibrium, although it's higher. The conclusion 4 is that if you look at market with current practices, that is LAYY, then it is not at the Nash equilibrium, which is the Cournot-Nash equilibrium, but it is between the Nash equilibrium and the competitive equilibrium. That's the average distance. So also the joint maximum doesn't hold, that can be rejected. So basically one possibility was that you would get a leader-follower model in which one of the bigger firms would become the leader. So basically, in the end, they say that we don't have a theory of what's happening, and we don't have a theory of what the practices do. And they say that the structure of the experiment was such that it was difficult for the people to get to the Corno equilibrium, to the joint maximum. So by just indirect signals and by changing things, they could have made it easier. And that's something you could test, that can we facilitate convergence to joint equilibrium. So this was one of the papers. Now let me briefly go through the other paper. Oops. Alright, so it starts by saying that there's a real problem that economic theory doesn't tell us about the what will happen in markets with few sellers. So either if you have a monopoly, then we have a theory. If you have a perfect competition, then we have a theory. But if you have an oligopoly, then we don't have a theory. So either you have non-cooperative game theory, Nash equilibrium, but there are multiple Nash equilibrium. Alright, so they designed this, which you have all seen once, that they carried out this experiment where they had the supply curve and the demand curve remained the same throughout the experiment, so that the competitive equilibrium remained the same throughout the experiment. But what they did was they changed the structure of the market so as to create market power. And how they did that was that there was a total demand of 8 units at a very high price, and then there was a demand of 3 more units at a low price. And all of the supply was available at the lower price, so the competitive equilibrium was at the lower price. But now if one of the sellers has 4 units to sell, then he gets 2 strategies. He can either sell all 4 units at the low price, which would be equilibrium, or he can keep 3 units off the market, and then the total demand would be 8. And now he has 1 unit, but 8 units are demanded at a very high price. So then by keeping 3 units off the market, when the total supply is 8, then everybody can charge a very high price. So if one of the sellers has 4 units for sale, then he has the option to not sell 3 and to just get a very high price for 1 unit, and that could be compensate for the loss of the sale on the 3 units, because the gain from selling the 3 high cost units is low, because the cost of those 3 units is high. So one of the units he has is low cost, and so he can make more profit by selling 1 unit than by at a high price than he can make from selling all 4 units at a low price. So that's basically the setup. And then they go through the calculations which show that what is the price at which you have it is better to sell for only 1 unit. And they also look at the impact of this on the other sellers. And then they go through a complex calculation of the Nash equilibrium with 5 sellers. But the problem is that this Nash equilibrium doesn't apply. So all this calculation is in some sense useless, especially because the Nash equilibrium here that they calculate is a randomized equilibrium. See, so let me explain the concept of a randomized equilibrium. Basically, you have a game which is called matching pennies. So, 2 people are playing the game, and I flip a coin and I hold it, and if you guess correctly, then you win, and if you don't guess correctly, then you lose. So now, how should the person behave? Should I fix it at heads or should I fix it at tails? Well, the thing is that in this situation, the best thing to do is to be unpredictable. And so that's what leads to a randomized strategy, that I should just flip the coin. Instead of, see, I have 2 options. I can try to guess what you will guess and then do the other thing, or I can just randomize. So it turns out that randomize is the optimal strategy because it makes it the most difficult for you to guess what I am going to do. So that's the randomization. So basically, in some situations, neither of the fixed strategies, you say I have a fixed strategy, I can play heads. Now, if I play a fixed strategy heads, and this is known to you, then you will always win and I will always lose. So if I play any strategy which you know about, then I will lose. But if I play a strategy which is that I will flip the coin and randomly I will choose heads, then even if you know my strategy, you can't guess what will happen, and then I will not lose. So there is a large part of the paper which is devoted to the calculation of the Nash equilibrium. But the Nash equilibrium has no explanatory power, because what happened doesn't really correspond to any of the Nash equilibrium. So the key diagram is this one, which shows what the players did. So basically, they do not analyze this diagram. This is it. So basically, in the first diagram, that's the first set of 20 or 30 games, I don't remember. 30 games. So this is basically what we want to do last, that in these games there are 2 large sellers who have market power, and then there are small sellers which have the square dots. So the plus and the plus sign and the multiplication signs, these are the large sellers, and then there is the dots, these are the small sellers. So if you see that the plus sign maintained his high prices throughout the game, except for in the third game he jumped to the competitive equilibrium, and then in the 11, 12 and 13 game, he tried to experiment with lower prices, slightly lower prices, but then he went back, and basically he was setting the standard for high price, and other people were more or less following him. Then again there was a small price decline in period 21 to 27, 21, 22, 23, 24, 25, and then from 25, 26, 27 the high price seller maintained high price. Then in the last few periods before 30 there was a general decline. So why this happened, nobody knows. And their theory has no explanation for what was happening here. In the second period, where there was no market power, the prices all declined rapidly. They started out by knowing that the high price, and so they started all at high price, but eventually, because they could not, in the no market power situation, in the market power situation, what happens is that you can sell 1 unit. I mean, you have 4 units, so there is always 1 unit of demand. In the no power situation, if you maintain a high price, it's possible that you will not sell anything, and so you will get a huge loss, and that's what happened here. So ultimately people realized that you can't charge high prices, and so they converged to the competitive equilibrium very strongly here, when there was no market power. So they used two design. They ran 30 games with power and 30 days without power, and these are the results that were obtained. So in the first session, session 1, with no power, there was convergence to competitive equilibrium eventually, and then with power the prices increased and they fluctuated very wildly, coming down to competitive equilibrium, then going back up, then going back down. And nobody knows why this happened, because we don't have a theory of behavior. So that's again something you can experiment and learn to see why do people behave like this. And if we have, so we need two elements in order to be able to explain this. One is a theory of how people make decisions under uncertainty, which is not expected, which does not give them information that they don't have. Instead, they should be working with what they can see and hear and observe. And the second is theory of learning. What the people do in the light of past experience. So, as we have said, one of the ways to get this is to ask the people to give instructions to an agent who will play the game on their behalf. Then they will be forced to articulate the rules that they use. That gives you access to the inner thinking of people. So in session 2 there was power and the prices were high. Then there was no power and the prices started from where they were, but they declined quickly to the competitive equilibrium. In session 3, no power. Now we have a very strange situation where prices declined to competition, then they went back up, then they declined again. In the power treatment, prices stayed comfortably up. Initially they declined towards competitive equilibrium, then they jumped up, and then they stayed up, although there were two more tendencies to decline. So again, nobody knows why this happened. In session 4, you really have an anomaly where the with power prices declined way below competitive equilibrium, but then they jumped back up. And in the no power treatment, again you have convergence to competitive equilibrium, but then failure to stay at the convergent price, and average price jumps up. towards the power treatment and then goes back down. Now session 5, the first session is very much according to theory. There's no power and we are in competitive equilibrium all the time. But session 5 doesn't quite behave properly in the sense that you have power treatment but the prices stay up, but then they start declining and they go down to equilibrium. Not equilibrium but a low price, and then it jumps back up. Now session 5 is again, session 6 is a bit strange. You start with power and you have high prices throughout, that's fine. But but in the no power, the prices stay quite high, they jump towards equilibrium, then they go right back up, so there's not much, they never reach competitive equilibrium. So okay, basically these are the results of the experiment. Now the way that the economists work is that they try to find a model which will have an equilibrium which has this property, and that will never work. But the thing is that what we need to know in order to understand these games is what the people were thinking and how they were learning. And this information we don't have, so unless we run our own experiments we can't understand. But basically, alright, so what we learned from this experiment is that market power matters. So basically in the previous experiment where we had 4 sellers, so there was a lot of market power. The 2 big sellers could control what was happening, and so we saw a lot of monopolistic type results. If you have a large number of sellers, then you would expect to see less market power, and so you would see collusion. And if you run experiments, you can try what happens with tacit collusion or with explicit collusion. These are experiments, because you see that the effects of collusion are high. You can get to the joint maximum, and so issues of when you can create collusion and what causes collusion to break down, these are important, and these depend very strongly on the microstructure, something which economic theory is very weak at predicting. And this also depends on how people make decisions. This is again something which is not part of economic theory. Economic theory doesn't understand how people behave. And then it depends on how people learn from experience, and again this is not part of modern economic theory. So again, economic theory is very poor at predicting results. So as a result, we have these experiments, and the way economists are trying to understand these experiments is also not a good way, because they keep thinking in terms of how can we fit a model in which people are optimizing something and people are converging to equilibrium, and this is not the right way to understand human behavior. So we have the opportunity to do a lot of work, we can take very simple experiments and try to understand how people behave, and the goal is to try to explain the actual data that you see on the basis of our understanding of human behavior. Now all of us are experts at understanding human behavior, even though we are not experts at calculating differential equations. That's because differential equations don't describe human behavior. So the idea that we can use differential equations and probability theory to understand human behavior, this is the idea of economists. This is wrong. That's why everybody in Pakistan, the students of economics, have great difficulty understanding the theory of consumer behavior or the theory of subjective expectation, because they're all human beings, they behave, but they don't understand how they themselves behave, because they are supposed to behave according to mathematics. So this is a sort of a strange situation where you don't understand how you behave in experiments, and the economist is going to tell you how you behave or how you should behave. So instead of that, just reject that and try to understand real behavior, and you will make progress in economics.